Hello everybody, welcome to this video. Today we are going to solve a problem from GATE 2024 Electronics and Communication Engineering session. This is question number 31 and the problem statement is to find Ix, and here we are given the electric circuit and we are going to use the following tools, that is KCL, Ohm's law and KVL. Kirchhoff's current law states that in a particular node, summation of the incoming current is equal to summation of the leaving current. Ohm's law is V equal to IR, where V is the voltage measured in volts, I is the current measured in amperes, and R is the resistance measured in ohms. And Kirchhoff's voltage law states that in a closed loop, the algebraic sum of voltages is equal to 0. Now we are going to follow the following steps to solve this problem. Step number 1, apply KCL so that you will get equation number 1. And step number 2 is to apply KVL to get equation number 2. Then we are going to substitute equation 2 in equation 1 so that we'll get the answer. To start with, we mark the nodes. This is node number 1, this is node number 2, and this is our reference node. And we have a super node here, that this node 1 and 2 together forms a super node. What is a super node? It is the combination of a node. In between this first node and the second node, we have a dependent voltage source which is not directly connected to any reference. That's why this is called as a super node. This forms a single node. Now we go for our solution. This is our first step. So we are going to apply KCL at super node 1 and 2. So we know that summation of incoming current is equal to summation of leaving current as the KCL. So here summation of the incoming current, here if you check, only this 5 milliamps current is entering into this node. Okay. So it is 5 into 10 power minus 3. And we have 3 number of leaving currents. This I0 is leaving this super node, 2 milliamps is leaving, and similarly this Ix is leaving. So it is the summation of these 3 currents, I0 plus 2 milliamps plus this Ix. And we are going to equate these two. So 5 into 10 power minus 3 is equal to I0 plus 2 into 10 power minus 3 plus Ix. Variables I0 and Ix at one side. We are bringing this 2 milliamps to this side, so that 5 milliamps minus 2 milliamps, you will get it as 3 milliamps. So we get the first equation, I0 plus Ix is equal to 3 milliamps. Now we move on to the second step, in which we are going to apply KVL, where the super node is included. So we are going to have loop 1 here. So we start from here and travel through this path, and this path, and then finally it ends here. So when we start from this point, here we have this minus sign and plus sign. This is actually marked by us. Why we have marked like this? Because the current is coming downwards, flowing from positive potential to negative potential, or the higher potential to lower potential. That's why we mark the polarities like this. When you want to apply KVL, we start moving in this direction. So it is from minus to plus. So we can write this as minus I0 into this resistances. KVL is nothing but a voltage equation. So each and every term should be in the form of voltage. There we applied this Ohm's law. Okay, V equal to IR. So this is I, this represents R. So here we have this minus I0 and it is passing through this 1 kilo ohm. That's why it is represented as 1 into 10 power 3. Then we go through this path. We have the voltage of minus 1000 I0. So we have written this. So this is already in the form of voltage. Then we move on to the third path. This is our third path, in which we have this current 2 milliamps which is flowing, 2 into 10 power minus 3. Then the resistance is 1 kilo ohm. That's represented as 1 into 10 power 3. So this summation is equal to 0. So here you have this minus 1000 I0. Here also this is minus 1000 I0. Then here you have plus 2, because this 10 power 3, 10 power minus 3 get cancelled. So it becomes 2. Okay. So here you have minus 2000 I0, that is equal to minus 2 when you bring this 2 to this side. So 2000 I0 is equal to 2. I0 is equal to 1 by 1000. That means I0 is equal to 1 milliamps. This is our second equation. Now we move on to the third step. So for that we have to refer this equations 1 and 2. So we are going to substitute equation number 2 in equation number 1, because here in equation 1 we have I0 and Ix. In equation 2 we have only I0. So this I0 value can be substituted in the first equation where we have this I0. So that this 1 plus ix is equal to 3, ix is equal to 3 minus 1, which is equal to 2. So ix is equal to 2 milliamps. This is our required answer. So we can have these things in a one shot. Hope you have enjoyed this video. Thank you.